Okay, 3.2 is going to start the majority of what we're going to be looking at in Chapter 3, this idea of truth tables, okay? All a truth table is an organized list. That's really it, okay? Kind of a list person. I'm maybe like borderline OCD. I really like lists, okay? To-do lists are one of my favorite. Does anybody ever add something to their to-do list after you did it just so you can mark it off? Yeah, I'm weird. I know. I do that. I know I'm not the only one, though, because I have friends who do it, too. All right, so I'm a list person. I think that way. That's just how my mind is structured, all right? Some of you may like lists, and some of you may not, but this is an organized list, and that's all a truth table is an organized list, okay? So I want to talk about a couple different kinds of truth tables. The first one is a truth table based on a conjunction. Now, we saw this word last class period. What does conjunction mean? This is not what this says. I'm asking a different question. What does conjunction mean? It means joining two statements with the word and. Okay, so whenever you see conjunction, you should be thinking, hey, we're talking about the word and. And we're talking about the symbol that looks like what? Exactly, that upside down V. So when we joined, we did this last time too, two statements with symbols with the word and, it looked like this. So far, so good? All right. I'm going to show you what a truth table looks like, and as a way of describing how this works, I'm going to create an example as we go. This doesn't always work out real well, but we're going to try it anyway. Okay, that's not what I wanted. Okay, so you're going to create one column that says P, one column that says Q, and one column that combines the two together with P and Q. Now let me talk first about the structure of the table. When I have two statements, P and Q, the structure always starts out the same. Now, the good news for that means that no matter what happens after those first two lines, you can always write them down, which means you can always get points even if you get stuck beyond that. That's good news, right? I always want points even if I can't finish it. I mean, those points add up, so get what you can sometimes, right? All right, so one possibility when you're given two statements is that both statements are true. That can happen. A second possibility would be the issue of the first statement being true and the second statement being false. Or just maybe the first statement was false and the second statement was true. And the only possibility that I have yet to write down is false, false. This is all the possibilities. Every single way that this can possibly happen when you're given two statements is this list of four things. Okay? So anytime you create a truth table, it will always have this pattern. It will have two T's and two F's underneath the first column, which is going to be P or whatever first letter you're dealing with. And then it will oscillate TF on the second column. It always starts out this way. And anything you see in the back of your book, if it's looking for the final column answer here, it's always going to have done it in this order. So if you hope to check the back of the book and see if you did the answer right, you have to stick with the order they're giving you. Okay? Now, as a way to describe what this is talking about, I'm going to use myself as an example. All right? And the statements I'm going to use say the following. Statement P is going to be, I teach math. And statement Q is going to be, I am a mom. Okay? So I should say, I teach math. So these are two statements. So what I've done is I've created a description that allows me to take two different statements and put the word and between them. So if I go out in the hallway and I walk back in and I come back in and I say to you, I teach math and I am a mom. Well, you know I teach math because I'm your math teacher. You know I'm a mom because I talk about my kids every now and then, right? So both of those statements are individually true. So if I join them with the word and, is the statement true or is it false? It's true, because both of the individual statements are true, right? So the result over here is a T. If both the individual statements are true, the result's true. All right. Now, has anybody had Dr. Nichols for a class? How about Dr. Marsh? Okay. we'll use Dr. Marsh since at least two of you know who she is. Dr. Marsh is a colleague of mine. She's office straight across the hall from me. She teaches math. If you're in elementary ed or special ed, you will have her for a math class at some point, okay? Dr. Marsh does not have children, okay? She's married, she's no kids yet, all right? So if she walks into this room because I'm sick and she's substituting for me someday, let's say, and she walks into the room and she says to you, I teach math, you're going to say, yes, I heard about you. You do teach math, right? And I'm a mom, you're going to say, now wait a minute. Dr. Hand said you aren't a mom, right? So if Dr. Marsh walks in and she says, I teach math and I am a mom, is that a true statement? No. Because in order for the statement to have been true, each of the individual component statements would have had to have been true, right? And that's what the description up here says. This statement is true when both statements are true. So if Dr. Marsh came in and she made that statement, it would be a false statement. Okay? So next thing we're going to use is, let's say, I need an example. Oh, here's a good one. We'll go with this one. We'll use political figures. Mrs. Obama, she walks in. Okay? And she says, which would be pretty exciting, whether you like her or not, it'd be pretty exciting if the president's wife came to your school, wouldn't it? I mean, it would be pretty cool. So she walks in and she says, I teach math and I'm a mom. You would say, no, what's wrong? She doesn't teach math. She's not a math teacher, but she is a mom, so part of the statement was true, but in order for the statement altogether to have been true, both of those components have to be true. So if she walks in and she makes that statement, that would be a false statement as well. Okay, I've got my last example. You all know this person. If you don't, you should know this person. Who knows Dr. Whitlock? Okay, a few of you still aren't so sure. You know, like the president of the university? Okay. All right, Dr. Whitlock, if he walks into the classroom and he says, I teach math and I'm a mom. It's going to sound funny, first of all, right? But he also doesn't teach math. He was never a math professor. I mean, he was a professor, but not a math professor before he became a president of a university, okay? So he doesn't teach math. That is not a true statement. Clearly not a mom. He's dad, but he's not a mom. Okay, so also not a true statement. So if he walks in the classroom and he says, I teach math and I'm a mom, you're going to say, false. That's a false statement. So when we're working with a truth table that joins things with the word and, the only time it's true is if both individual statements are true. Are we all good with this truth table? Awesome. Let's do another one. We had an and statement. That was a conjunction. A disjunction is a or statement, or is an or statement, I guess. And or used what symbol? The V. So we have P, it looks like a V then, and Q there. Okay. I know you're writing down the statement here where it says true when either one or both statements are true. It'll make sense as we work through the example. The first two columns underneath P and Q, you know how they are because they're always the same. What goes underneath my P column? True? True. False, false, exactly. Always starts out the same way, right? What goes underneath the Q column? Right, true, false. True, false, and even if you can get nowhere else, you should be able to fill in those two columns because they're always the same. All right, so we're going to use the same statements that I did before. Same people as examples and everybody, okay? So same as before, we've got teaching math and being a mom. So here's math, here's mom. And I come into the classroom one day, and just because I decide to talk to you about it, I just come in and I say, I teach math or I am a mom. Is that true? Yeah, I mean, I happen to be both, but it's true. It's an awkward way of saying it maybe, but it would work. Be a true statement. Next, Dr. Marsh comes in. Dr. Marsh comes in and says, I teach math or I'm a mom. It's true, right? She does. She teaches math, or she's a mom. She's one or the other. Yep. Mrs. Obama comes in and she says, I teach math or I'm a mom. That's true, because she's a mom. And then Dr. Whitlock comes in and he says, I teach math or I'm a mom. That's false. It's false because both of the individual statements were false. So if you compare this truth table to the other truth table, they have some things in common. Namely, the top line, 2 individually true statements are always a true statement, whether it's an and or an or that joins them. And 2 individually false statements give you a false statement, whether they're joined with and or. It's just the middle 2 lines that are different, right? With an or statement, you just need one of these pieces to be true to give you a true statement. And with an and statement, both of them would have to be true to give you a true statement. All right, we're going to do an example of how to create truth values next. Now, the directions here, oops, I underlined the wrong one, have this phrase that's important. So let's read what we have. It says, let P represent a false statement. That's important. So P is false. And it says, let Q represent a true statement. So Q is true. And it says, find a truth value of the given compound statement. So what does that mean? Well, the first statement is really straightforward. It only has one letter. So I don't need a column for P and a column for Q because this statement right here does not involve Q at all. Are you with me? So I won't start out with a P and a Q because there is no Q. All this is tilde P. So if I were creating a table kind of like what I did on the previous slide, I just need P as a column header. It's the only letter present here. But if I have a column header for P, I'm also going to need a column header for what?
Tilde P.
Tilde P, the only other piece that's here, right? Now, if I were creating a truth table, I would still have to say P could be true, P could be false, and I could go on from there. But I'm not. The directions say, what am I looking for? A truth value. And it gives me information to help me do that. It tells me that P is a false statement, which means I don't have to explore all the possibilities. I'm told P's false. So I can just fill it in. It's false. And if P is false, what is tilde P? It's true, because it's the negation. It's the opposite. This is the work you have to show. And are there other ways to do it? Yes, but they don't lend themselves to all aspects of what we're going to be doing. So this is what I want to see. I want to see this sort of a miniature truth table, this one-line thing going on. And then you have to give me the answer. Because the question didn't say create a miniature truth table. The question said find a truth value. The truth value is the last piece. This right here tells you that your answer is true. So you have to write down that that is your answer. I don't want to have to decide, looking at your paper, whether or not you know what you found and whether you found the right thing. I want you to tell me, I know I found the answer and the answer is true. Okay? Now, the second run right here, which is on the next page of your notes, does involve P and Q, as in both of them. So I have P, I have Q, and like in algebra, when you see parentheses, they group things together, like what we did with Venn diagrams, right? When you saw parentheses, it meant do the stuff inside first. Same thing here. I've got parentheses, so I'm going to do the stuff inside first, which means the next thing I'm going to do is have a column that says what? Oops.
Oh, yeah.
The inside the parentheses first. We'll get the tilde in a sec, though. We need a column that represents what's inside the parentheses. Okay, so we're starting out inside. Little piece here, we make a column for P. Little piece here, we make a column for Q, and then we join them together. This is what we did with Venn diagrams. We found everything in set A, we found everything in set B, and then we somehow joined them together, unions or intersections. Okay, so this is the same feel to it. And then moving outside of my parentheses, then I'm going to get my tilde, right? So my last column is going to join all the pieces finally together. It's going to have a tilde, and then it's going to have the P and Q. Okay, again, if I were doing a truth table, I would have T, T, F, F, T, F, T, F. I mean, that's what it would be. But I'm not. These directions say it wants me to find a truth value. And they give me what I need to do that. They tell me that P is false. And they tell me that Q is true. So I don't need any of the other T's and F's. They do not apply to this particular case. Right? This would be like Dr. Whitlock walking in and you looking at it and saying, I don't know, he might be a mom. No, he's not. We don't have to explore any other possibilities. A man walked in, he's not a mom. Okay? That's the equivalent of this. So now taking a look, this statement joins them with the word and. If you have a false statement and a true statement and you put the word and in between them, what happens? That's false. So we fill in false. Okay, this was Mrs. Obama walking in and saying, I teach math and I'm a mom, and you saying, no. One of these things is not true. Okay? But what happens when we put a tilde on something? It negates it, right? It does the opposite. So it takes what this is in parentheses, which was what the column before represented, and it negates it. So what's going to go down here? True. Am I done? It's catch-22, right? No, I need to write the answer. What's the answer going to say? True. The answer to the question is true. The work that supports it was this sort of a one-line truth table. Okay? Let's see where we are. Okay, similar thing on the next slide. Similar directions. You see a phrase that's very friendly, and you see some details that are helpful. So the helpful details tell you that P is true, and it tells you that Q and R are false, and it asks you to find the truth value, right? So the only difference between what this is and the last ones are that we have 3 statements instead of just 2. I mean, that's really the only big difference. So when I create my truth table, sort of the work I'm going to draw here, I need a column for P, a column for Q, and a column for R, because I have 3 letters that I'm working with. Okay, so we start with P, Q, R. I can put the T's and F's and whatever in there, and that's great. But what am I going to list as my next column header? What piece of this comes next? QVR, and how do you know? Because it's inside of those brackets, those parentheses. So QVR comes next. And then what? Somebody said everything. Yeah, the part with the P and the and at the beginning. So now I get to kind of attach that piece on. So we've got P and QVR. So there's a lot of space on your paper. You don't end up needing all that space because we don't need a whole truth table here, right? All we need is the truth value. You were told P is true, Q is false, and R is false. Those were given to you. Put them in. Even if you mess up after that, at least you've got those pieces in there right. All right, now it says QVR. So that means I look at the Q column and the R column only, and I join them with the word or. So false or false is a false statement. Okay? Next, I look at the P column, because that's what this says right here, right? and I look at the Q or R column, which is the one I just created, so both the columns that I've marked in pink are what I'm looking at now, and I'm joining them with the word and it matters now, doesn't it? Because if I were joining them with the word or, something different would happen here. But I'm joining them with the word and. So I'm taking a true statement and a false statement, and I'm joining them with and I get false. So the answer is false. And the work to support it was that one-line table above. Okay. So I keep saying I haven't had to do a whole truth table yet, and I haven't. I want to talk about how, when you work with a truth table, how you know how many rows and columns and whatnot you have. So if you're dealing with creating a whole truth table, which is what we're about to do, is to actually create a whole table instead of find a truth value, you need to know how many rows you would have in the table. So if you have n component statements, that's n letters, so you've got Q and R, or you've got P and S, or you've got Q, R, S, P, whatever. However many letters you have, those are the component statements. The number of rows you have is 2 to the nth power. And you've seen that formula before. What did we see that used to find before? Subsets. Because what it really does is it tells you the number of ways of combining things together. And that's what we're doing here. The number of ways of combining things together. So 2 to the n. So we already did an example of a whole truth table, 2 of them at the beginning, a conjunction one and a disjunction one. When we did those, how many component statements did we have? That's how many rows we had. Component statements are the letters. How many letters did we work with? 2. They were P and Q, right? Let me flip back to this so we can talk about this concretely. Well, that one would have been fine. There were 2 component statements, P and Q, right? And how many rows did we end up with? 4 rows. Okay, so rows are the horizontal, okay? Not columns. We're talking about rows. So we've ended up with 4 rows. And what this argument is telling us is that we should have ended up with 2 to the second rows. And what is 2 to the second? 4. And we did end up with 4 rows, didn't we? Okay, so not today, but next class period, we're going to do this one over here. How many letters, distinctively different letters, do you see? There are 3. How will I find the number of rows?
What, Miss?
We're going back, Leah. I'm just asking a question, okay? 2 to the third. So when we get here next time, I'll have 2 to the third, which is what? 8. I heard some 8s, yeah. That's 8 rows. So when we have 3 statements, we'd have 8 rows. Okay? Let's go back to this one right here that I skipped over. How many different letters do you see? There are only 2. I mean, there's 3 letters listed, but some of them are duplicated, right? So you don't count them twice. If Q's there, you only count Q once, even if there's a Q and a tilde Q. Right? There's only 2 different letters. So I'm going to end up with 2 squared rows, and 2 squared is 4. All right, so let's create those rows, and it makes sense because we've already talked about the structure of how this works. You're going to have a column for P and a column for Q. What else are you going to have a column for?
The one in the post.
We are going to work inside the parentheses, but we're not ready to do everything inside the parentheses just yet. I need a tilde. A tilde what? Q. Because, see, what I want to join is I don't want to join P and Q together. I want to join P and tilde Q together, and I don't have a tilde Q column yet. So I need that tilde Q column. Once I have the tilde Q column, then I can combine the P and tilde Q together, which is everything inside the parentheses. And then what? Then join it with what's outside, right? Then I can join the P and tilde Q and do that with or P.
Uh-oh. That ends up to 5.
it ends up to 5 columns.
Ah.
But the formula is for the number of rows. Okay? So let's fill in our 2 rows at the beginning. I'm sorry, our 2 columns at the beginning. Now I'm all mixed up on my rows and columns. Fill in our 2 columns at the beginning because you know how those fill in, and then we'll fill in the rest of it next time. So column P will say what? True, true, false, false. And it will always say that, won't it? And column Q will say true, false, true, false. I hate to quit in the middle of one. Maybe we should just finish it. What's column Q going to say? Column tilde Q going to say? Right. So why is it going to say false, true, true? Because why? It's the opposite of column Q. So whatever column Q said, we're just going to reverse it, right? If it said true, now we're going to say false. If it said false, now we're going to say true. Now, the next one actually tells us that we're supposed to join column P with column tilde Q, right? Those are the 2 we're joining, and we're joining it with the word and. When is an and statement true? When both statements are true. So along the top, I've got T, I've got F, which means the statement is false. Second row, I've got a T and a T, which means the statement is true. Third one, I've got an F and an F, which means the statement is false. Last one, I've got F and T, which means the statement is false. How would what? Remember, this is when Dr. Whitlock walks in and he says, I'm a mom and I teach math. And you say, no, neither one of those are true. So 2 false statements is still a false statement. And a false and a true statement would still be a false statement as well. Both have to be true for the word and. Okay, we've got one other thing to do to finish the table out then, and that is to compare the column we just created, the stuff inside the parentheses, with the column P, which was what this statement at the end says to compare, right? Compare this statement with the word or and the statement P. So now I'm looking at the statement I created, the last step, the original first step, with the word or. What does it take for an or statement to be true? Either one true. If either of the individual statements are true, the whole thing's true. So this first line says true, false. That would be true, because one of the 2 of them is true. The second one says true, true. So you get another true. The third one says false, false. That's false. And the last one says false, false. So that's false. All right. We'll stop there.